This is the best trick you can apply in competitive level exam, and you can solve any question in few seconds. Students, I have taken a lot of effort in making this video. Please like, share, subscribe my channel. This is Avin. I'm thankful to YouTube and millions of YouTube viewers. Hello friends, this is Avin. This is the second video on bond order. In my first video, I have explained you how to find the bond order for those molecules which contains 1 to 8 electrons, and we have also solved in that video many IIT JEE appeared questions. You can find that video in the playlist. In this video, I am going to explain you how to find the bond order for those molecules which contains 8 to 20 electrons with a solid trick. Here we go. Let us consider an example, carbon monoxide. Atomic number of carbon is 6, therefore it has 6 electrons. Atomic number of oxygen is 8, so it has 8 electrons. Total electrons in this molecule is 14. There are 14 electrons present in this carbon monoxide. So, in order to find the bond order for such molecules which contains more than 8 and up to 20 electrons, we are going to learn one amazing trick, and this trick I will explain you first, then we will solve many IIT NEET previous appeared questions. What we have to do is, we have to make 3 columns: number of electrons, bond order and unpaired electrons. We have to write 14 first. We have to write 14. If the molecule contains 14 electrons, its bond order will be 3. We have to remember this one. Only thing we have to remember, if number of electrons are 14, its bond order will be 3. For example, in this carbon monoxide, the number of electrons is 14, therefore the bond order in carbon monoxide is 3. Therefore, the carbon monoxide molecule has structure C triple bond O. So, we have to remember only one number, that is 14 electron means bond order 3. Then number of electrons 15, 16, go on writing 17, 18, 19 and 20. Now, to find the bond order of molecule containing 15, 16, 17, 18, 19, 20, just you need to subtract 0.5. If the molecule contains 15 electrons, its bond order would be, you have to reduce 0.5 from 3. It becomes 2.5. Go on reducing 0.5. It becomes 2.0. If molecule contains 17 electron, reduce 0.5 from this, it becomes 1.5. If the molecule contains 18 electron, reduce 0.5 from 1.5, it becomes 1. If the molecule contains 19 electron, reduce 0.5 from 1, it becomes 0.5. If the molecule contains 20 electrons, reduce 0.5 from this, it becomes 0. Therefore, if the molecule has 20 electrons, its bond order will be 0. If the molecule has 19 electrons, its bond order will be 0.5 and so on. If the molecule contains 13 electron, 12 electron, 11, 10, 9 and 8. Same thing you have to do. You have to go on reducing 0.5 from this. From 3, if we reduce 0.5, it becomes 2.5. Again reduce 0.5, it becomes 2, 1.5, 1, 0.5. And if the molecule contains 8 electrons, its bond order will be 0. Now, how to find the unpaired electrons present in the molecule? If we come to know how many unpaired electrons are there, or if we come to know whether unpaired electrons are present in the molecule or not, we can answer for those questions related to magnetic property. We can decide whether the molecule is paramagnetic or diamagnetic. If the molecule has unpaired electron, it is paramagnetic. If the molecule has paired electrons, it is diamagnetic. Such questions can be answered if we know whether unpaired electrons are present in the molecule or not. How to remember whether the molecule has unpaired electrons or not? If it has unpaired electrons, how many unpaired electrons it has, how to remember how many unpaired electrons a molecule has. I give you a solid trick for this. What you have to do is you have to write 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. We have to write 0, 1, 0, 1, 0, 1 up to 20 electrons. Now we have to make one important change. If the molecule has 10 electrons, see, if the molecule has 10 electrons, instead of 0, you have to take 2 unpaired electrons. And if the molecule has 16 electrons, you have to take, instead of 0, 2 electrons. So these are the number of unpaired electrons for the molecules containing 8 to 20 electrons. If the molecule has 8 electrons, its bond order is 0 and it has 0 unpaired electrons. If the molecule has 9 electrons, its bond order is 0.5 and it has 1 unpaired electron. So this molecule having 9 electrons, it has 1 unpaired electron. That means it is paramagnetic in nature, and this molecule must be colored. If the molecule has unpaired electrons, then it shows paramagnetism as well as it is colorful. So if, for example, if we consider 13 electron, molecule having 13 electrons, its bond order is 2.5 and it has 1 unpaired electron. And molecule having 14 electrons, its bond order is 3 and it has 0 unpaired electrons. When the molecule has no unpaired electrons, that means it has completely paired electrons, so it is diamagnetic in nature and it is colorless. What is paramagnetism, what is diamagnetism, I have discussed in detail in my first video. If possible, you can watch that video also. If we consider carbon monoxide, it has 14 electrons, so it has bond order 3 and it has 0 unpaired electrons. Therefore, it is diamagnetic in nature and it is colorless. Now, let us solve very important JEE Neet appeared questions, and I have taken a lot of efforts in making this video. Please like, share and subscribe my channel. Now we will go for important previous appeared questions. Question: which of the following has highest bond order? This question appeared in Neet 2018. Option A Cn plus, option B Cn minus, option C NO, option D Cn. Before we solve this question, I will make a recap of this trick. We have to make 3 columns. First column is of electrons, second column is bond order, third column is number of electrons. We have to write 14 electrons and we have to remember its bond order is 3. Then we should go on writing up to 20. 15, 16, 17, 18, 19, 20, and we should go on reducing this 3 by 0.5. When 0.5 is reduced from 3, it becomes 2.5, 2.0, 1.5, 1.0, 0.5 and 0. In the same way, molecules having less than 14 electrons, we should go on reducing 3 by 0.5. Then, how to write the unpaired electrons? We have to write 0, 1, 0, 1, 0, 1 up to 20 electrons. Then for the molecule containing 10 electrons, we have to write, instead of 0, we have to write 2. And for the molecule containing 16 electrons, instead of 0, we have to write 2. This is the thing we have to remember, and when we know how to write this chart, we can solve any questions related to bond order, related to bond length, related to stability, related to magnetic properties and related to bond enthalpy. Now let us solve this question, which has the highest bond order. They have given Cn plus, Cn minus, NO and Cn. We have to find the bond order. Here the atomic number of carbon is 6. That means it has 6 electrons, because we know that atomic number is always equal to number of electrons. So atomic number of carbon is 6, so it has 6 electrons, and nitrogen has 7 electrons, but there is a positive charge, that means it has lost one electron. Therefore, the total number of electrons present in Cn plus is 12 electrons. 12 electrons means its bond order is 2.0. Its bond order is 2.0. In case of Cn minus, carbon has 6 electrons, nitrogen has 7 electrons, and there is one minus charge, that means it has gained 1 electron, therefore it becomes 14. When molecule has 14 electrons means it has bond order 3. Then NO, nitrogen has 7, oxygen has 8 electrons, total number of electron in NO is 15, therefore 15 electrons means bond order is 2.5. Now, in case of Cn, carbon has 6, nitrogen has 7, it will be equal to 13. 13 electrons means the bond order is 2.5. If we compare all these bond orders, you will come to know that the bond order of Cn minus is 3. That is, it has the highest bond order. Therefore, answer is option B, Cn minus, its bond order is 3. Its bond order is 3. Now let us solve one more question. This question appeared in Neet 2017. They have asked find pair of species having same bond order. They have given 4 pairs. Now we have to find the bond order. To find the bond order, let us calculate the number of electrons present in this carbon monoxide. Carbon has 6 electrons and oxygen has 8 electrons. Total number of electrons in carbon monoxide is 14. Therefore, its bond order is 3. Its bond order is 3. In case of nitrogen monoxide, nitrogen has 7 electrons, oxygen has 8 electrons, 7 and 8, it is 15. 15 electrons means the bond order is 2.5. In case of oxygen, oxygen has atomic number 8, that means it has 8 electrons. 2 oxygen atoms means 16 electrons, and 16 number of electrons means the bond order is 2.0. That is, bond order is 2.0. In case of nitrous oxide, NO, that is, the nitrogen has 7 and oxygen has 8 electrons. Total number of electrons in NO is 15. Therefore, its bond order is 2.5. If we see this pair has different bond orders, so we have to find the pair of species having same bond order. Still we have to go. Now, carbon has 6 electrons, nitrogen has 7, 6 plus 7, that is 13. There is one minus charge, therefore number of electrons are 14. 14 means bond order is 3. Now, in case of carbon monoxide, here carbon has 6 electrons and oxygen has 8 electrons. 6 plus 8 means again 14. Then the number of electrons are 14. That means bond order is 3. Therefore, this option C, Cn minus and CO, this pair has same bond order. Therefore, this is the answer for this question. These are the species having same bond order. You have to remember one simple way. If the number of electrons present in the molecules, if the number of electrons are same in 2 molecules or 3 molecules, they have same bond order. I repeat, if the molecules have same number of electrons, they have same bond order. Now let us solve one more question. This question has appeared in the year Neet 2015. We have to find the correct bond order from these 4 options. To find this, we have to find the bond order of each molecule. Let us find the bond order of O2 minus. If we consider O2 minus, there are 2 oxygen atoms, therefore total number of electrons in 2 oxygen atom is 16, and there is one minus charge, therefore its number of electron is 17. 17 electrons means the bond order is 1.5. This is the bond order. In case of O2, total number of electrons 16. 16 means the bond order is 2.0. In case of O2 plus, The total number of electrons, that is 16. There is one positive charge. That means this molecule has lost one electron. Therefore, total number of electron is 15. 15 means the bond order is 2.5. 2.5. Therefore, the correct bond order is O2 plus has highest bond order, then comes O2, then comes O2 minus. If you observe in these options, you will find this option in B. Therefore, B is the correct option or correct bond order in this question. Sometimes they modify the same question and they may ask the correct bond length order. Means if they ask bond length order in the same question, you have to remember that the bond length is inversely proportional to bond order. Therefore, if they ask by giving the same question and if they ask the bond length order, then the answer will be O2 minus has highest bond length than O2 plus, because the bond length, as the bond length increases, bond order decreases. Therefore, the molecule having the low bond order, it has maximum bond length. Therefore, this is the correct order for bond length in this example. Students, I have taken a lot of effort in making this video. Please like, share, subscribe my channel. This is Avin. I am thankful to YouTube and millions of YouTube viewers.